In Topic 3, we learn about chemical formulas. Most of them require nothing more than some rules, patterns, and a periodic table. However, many formulas involve polyatomic ions, and those are a bit more complicated because they don't follow such simple rules or patterns. To fill out this table, you would need to memorize the polyatomic ions, but that would be just a practice activity. You would be more likely to encounter polyatomics in these types of questions, especially earlier in the year. For a more challenging version, we'll replace the formula with its name. As you move to more advanced chemistry topics, quick automatic recall of polyatomics will become more essential. See how often they appear? Memorizing all of these seems impossible, but you can do it. Let's start with the polyatomics that you are most likely to see. Say this sentence a few times, and say it with expression as if it makes sense that Nick the Camel ate clam and crepes for supper in Phoenix. Again, Nick the Camel ate clam and crepes for supper in Phoenix. Let's start with Nick. The N reminds us of the N in nitrate. Count the consonants. 3 consonants, so 3 oxygens in nitrate. Now count the number of vowels. There's 1 vowel, so nitrate has a -1 charge. The C of camel reminds us of carbonate. 1, 2, 3 consonants, 3 oxygens. 2 vowels, carbonate has a -2 charge. Clam sounds like chlorate. 3 consonants, 3 oxygens, 1 vowel, chlorate has a -1 charge. So Nick the Camel had clam and crepes for supper in Phoenix. Crepes for chromate, 1, 2, 3, 4 consonants, 4 oxygens, 2 vowels, chromate has a -2 charge. Supper for sulfate, 4 consonants for 4 oxygens, 2 vowels, sulfate has a -2 charge. And finally, we have Phoenix for phosphate. It has 4 consonants for the 4 oxygens in phosphate, and the 3 vowels tell us that phosphate has a -3 charge. Once we're comfortable with these 6, we can use them as a reference for the others. Did you notice how these end with "ite" as if they're the light version? For example, you already know that nitrate has 3 oxygens, so nitrite has only 2, but it has the same charge. We already know carbonate, so we can use that for hydrogen carbonate, which has 1 more hydrogen, and so 1 less negative charge. We already know chlorate, which has 3 oxygens. Chlorite is the light version, so it only has 2, and hypo has even less, it only has 1. Per is like hyper, it has more oxygen, so instead of 3, it has 4, but the same -1 charge. Sulfate is the one we already know. Sulfite is the light version, so it has only 3 oxygens, and hydrogen sulfate follows the pattern of hydrogen carbonate, which means it has a hydrogen in the front and 1 less negative charge. And then there's phosphate. This is the version we know. Hydrogen phosphate has that extra hydrogen and 1 less negative charge, and dihydrogen phosphate has 2 of those hydrogens and a -1 charge instead of phosphate's -3. At this point, you should be able to complete the table. Let's try phosphate. Phoenix is my clue. It has 4 consonants, so I write a P and 4 O's, and it has 3 vowels, so I add a -3 charge. Great, that is the formula for phosphate. You can use the clues to fill in most of these on your own. For number 1, we know phosphate. And periodic table patterns tell us that calcium has a +2 charge. We make the total charge equal 0 by having 2 phosphates and 3 calciums, and then it's easy to see that there are 8 oxygen atoms. For sulfate, supper is my clue. 2 vowels, -2 charge, which totals -6, which means the iron has a +6 divided by 2 atoms is a +3 charge per atom, and so it's written as iron 3 sulfate. And back to the chart of polyatomic ions. After learning the mnemonic, there are only 11 left to memorize. For those that don't work with Nick the Camel, you may want to try a memorization strategy called the Memory Palace. Your memory palace is a place that you can imagine very clearly. Attach anything you need to remember to actual things in your memory palace and try to make it come alive in your brain. Make your clues as wild and crazy and even as inappropriate as possible. The wackier the clue, the more likely you are to remember it. In my memory palace, cyanide is on the hand of this guy who's really a spy and might kill himself. Ammonium is in a puddle on the floor, and it's this great thing for cleaning, so it's positive. Peroxide is on the head of this woman who had her hair dyed a really bad shade of blonde, and it's so bad it's -2. Permanganate is on the spy's head because he has a really bad man perm that's made out of 4 oxygens. With clues, the sky's the limit. What matters is that they're yours, they're crazy, and you can remember them. You have learned mnemonics and memory strategies for the polyatomic ions. Now see how many of the formulas you can name. Once you've done that, read the names and try to write the formula for each one. Good luck!